Geometry, Lesson 1, 6b. We're continuing with two-dimensional figures, and we're going to learn about polygons. In the last video, you heard me mention the word region. A region is the union of a simple closed curve and its interior. The curve is the region's boundary. So the union of its interior and its boundary is the whole region. When we just speak of an interior, it is not in union with the boundary, unless we state so. Any set of points can be classified as concave or convex. A set is convex if every segment with endpoints in the set is completely contained in the set. What does this mean? This means that if I take a point here and a point here and I connect them, they are inside the set of the circle, or inside the set of points that makes the triangle. A set is concave if a segment can be drawn whose endpoints are in the set, example here A and B, but the segment can go outside the set. If I draw a line from A to B, you can see that the line goes outside the region or the shape. So a set of points is convex if if every segment with the endpoints in the set is contained in the set, and it's concave if you join two points and the segment goes outside the set. Let's talk about some more figures that are simple closed curves. A polygon is a simple closed curve that consists only of segments. So previously we had a circle, which was a simple closed curve, but it had no straight line segments. A polygon only has straight line segments. The segments are sides of the polygon, and each endpoint of a side is called a vertex. So let's look at this polygon here, polygon A. The segments are the sides, so you can see these straight sides, and they're all line segments. Each endpoint of a side is called a vertex. So this shape right here has 5 vertices. Are all of these polygons? Well, figure A and figure C are polygons. They are simple closed curves made up of line segments. B is not a polygon, though it has 4 sides that are straight segments. The 5th side is curved. D has line segments, but the beginning and the ending do not meet. It is not closed, so it is not a polygon. We classify polygons by using the prefixes to indicate the number of sides. There are different categories or classifications of polygons. We have the equilateral polygon, and that means that all sides have the same length. We have an equiangular polygon, which means all angles in the polygon have the same length. And if you have a polygon that is both equilateral and equiangular, meaning all the sides have the same length and all the angles have the same measure, that is called a regular polygon. Just like curves, polygons divide a plane into 3 disjoint sets: the polygon's interior, its exterior, and the polygon itself. As in circles, a polygonal region is the union of the polygon and its interior. To continue with polygons, we'll take a look at the names of polygons. Polygons are named by the number of sides. You're probably familiar with many of those that are listed. A triangle has 3 sides. The prefix tri means the number 3. A quadrilateral has the prefix quad. Quad means 4. A pentagon has 5 sides. Hexagon has 6 sides. Heptagon, 7. An octagon has 8. Think of an 8-legged octopus to remember that one. The nonagon has 9. A decagon has 10. For 11, we call it a hendecagon. And 12 is a dodecagon. There are many more, but these are the most common. If we're working with a problem where we have an unknown number of sides, we'll call it an n-gon. Let's look at example 3 on page 33. We're asked to classify each polygon by its number of sides. State whether it forms a concave or convex region, and whether it is equilateral, regular, or none of these. So, A, is it concave or convex? We can see that we could make 2 points inside of this polygon, and the segment would go outside, so that will make it concave. These 2 sides on the top are the same length as the other sides. However, the angles are not the same, and we can tell that because some angles have 1 arc and some angles have 2 arcs. So it is not regular. It is, however, 7-sided, so it is a heptagon. And it is equilateral because the sides are all the same length. Let's look at number B. Now number B is convex. All the points connected by a segment would lie inside. It has 1, 2, 3, 4 sides, so it's a quadrilateral. It is not equilateral. The sides are all different lengths, and it is not equiangular. So it is not a regular polygon. Looking at the last polygon, we have side lengths that are all the same and angles that are all equal. There are 8 sides. This is a convex figure. All the points connected by segments will stay inside of the figure. So it's convex. It is an octagon. And it is regular. Polygons are named by listing the vertices in consecutive order, either clockwise or counterclockwise. Looking at the pentagon to the right here. The pentagon is named, and you can start at any point, but I find it easiest to start with A. I'm going to go counterclockwise, and it is named A, B, C, D, and E. The points need to be consecutive wherever you start. If you start at B and go clockwise, it will be B, A, E, D, and C. The triangle would be named ABC or ACB or BAC, and you get the idea. Every angle of a polygon consists of a vertex of the polygon and two rays on either side. As an example, in the pentagon, vertex B is contained by ray BA and by ray BC. A diagonal of a polygon is any segment that connects two consecutive vertices. The diagonals of the pentagram are BD and BE. You could also draw AC, AD, and EC. I'm going to show you one of the easiest ways I know to do this. Let's start with A, and we'll try to connect A with any point that is not on the side. So the first diagonal would be AD, then AC. AE and AB are sides. Now I'm moving to point E, and EB is a diagonal, and EC would be a diagonal. EA and D are sides. If we go to D, we see that DA is already drawn, and DB is already drawn. C has CE and CA already drawn. So these are all the diagonals that we could draw. The triangle has no diagonals. It only has sides. Each vertex or angle of a triangle has a corresponding opposite side. In triangle ABC, the opposite side of angle A is BC. BC is the side that does not contain A. The opposite side of angle C would be AB. And the opposite side of angle B would be AC. The distance around a closed curve is its perimeter. In circles, we call the distance around the circle a circumference. In a polygon, we call it a perimeter. To solve the perimeter of a polygon, just add the length of the sides. In a regular n-gon, each side has the same length, so the sum could be found quickly by multiplying. Let me give you an example. If AB was 4, BC was 3, and AC was 3, we would add the sides, and the perimeter, or P, would equal 4 plus 3 is 7, 7 plus 3 is 10. This leads us to the theorem for perimeter of an n-gon. The perimeter P of a regular n-gon with the sides of length S can be found using the formula perimeter equals the number of sides times the side length. Or to shorten that, perimeter equals the number of sides times the side length. P equals NS. Let's look at an example here. A is not a regular polygon, so we'll add the sides. The sides are AC, CB, and BA. Substituting the numerical values for those sides gives us 4 centimeters plus 10 centimeters plus 8 centimeters, which equals 22 centimeters. So the perimeter equals 22 centimeters. In a regular polygon, we can use the formula. All of the side lengths are 9. So our formula is P equals NS. P equals the number of sides, which is 5, times the length of the side, which is 9. 5 times 9 is 45. What figure would be approximated by a regular n-gon as n, or the number of sides, approaches infinity? What this question is asking you is for you to imagine what a polygon would look like if you kept adding numbers of sides to it. This would be a regular polygon. So we've just shown you one that had 8 sides, but what about one that has 100 sides or 200 sides? What figure would you end up with? There's an animation that shows you this concept. Copy this web address and paste it in your browser, and you'll see what will happen. When you paste this in your browser, on the right of the screen, you'll see a box that says sides, and it'll say less or more. Keep clicking on the more and see how far you can go. Be prepared to explain in class what happens. See you soon.